So welcome and thank you for attending our session. My name is Kyle Cordova, and I'm the Associate Director of the University of California, Berkeley Global Science Institute. The session is titled Emerging Scholars, Establishing the Cycle of Innovation. As you see, we have a bunch of panelists of young scientists, so we're trying to focus on them today. It's co-organized with the International Institute for Applied Systems Analysis, or IASA, with Dr. Pavel Kabat. So the focus of today's session, I'm just going to give a couple opening remarks, is to address three main challenges that we see with the globalization of science. And the first one is what we call the wasted minds problem. And so when we look around, we see that there's a lot of young people who we call emerging scholars who have the will to improve themselves. They have the will to address local, regional, and global challenges, but they don't have the opportunity. So I hope today that we kind of discuss ways that we can provide more opportunities for emerging scholars in this panel section. The second challenge is the exclusiveness of science. And what I mean by that is that there's few scientists in few countries that are truly innovating to solve global challenges. In essence, you can think about it as there's really an unequal distribution of knowledge. So how do we build local research capacity to provide opportunities for young scholars so that they can solve local problems before they become global? And the final one, with IASA participating with us, we seek to discuss how emerging scholars can access governments and policymakers who have an impact on the science that we carry out. So we'll hear a little bit about that later on our panel. But before we begin with the panel discussion, I want to introduce our first keynote speaker, who is Professor Omar Yaghi. Earlier this week, he was announced as the Jordanian Star of Science, and he just got off a plane from the Netherlands, where he won the 2017 Albert Einstein World Award of Science. So I think we can applaud him for this big award.
Okay, thank you very much. I'm delighted to be here to share with you some of the work that we've been doing on globalizing research. What I want to focus on in my presentation is really about actualizing the process of doing research in countries that have nascent research culture, an emerging research culture, or some people call it developing nations. I think that we have developed a model that is based on working with scientists on the ground to help them in their own local environment on how to grow research and how to excel in research and be part of the international science scene. So I titled my presentation, Creating Vibrant Cultures of Science, and you need to be working with scholars such as our panel members one-on-one in order to be able to do that. But first, I want to just say that you have to have the science, because science is the language that everybody can understand and everybody can talk about without having to worry about borders, ethnic origin, color, race, gender. And so the way we started this is that, we didn't wake up one day and say, okay, we're going to globalize science. The way this started is that we invented new classes of materials that mushroomed in terms of the number of people working on them in the world. And so when I go around giving lectures on my research, after my lecture, many young scholars come up to me and they say, Professor, I want to do an internship with you, or I want to be a graduate student in your lab. And I realize that the desire of young scholars to engage in research is truly overwhelming and inspiring. So not all those people can come to my lab. So I realized that maybe we should just go to them. And so we started doing that, and we realized there is a great reception from many countries to establish research centers on creating new materials, but also it turns out that once you start engaging, once you start partnering with those countries, then the science agenda expands. It's not just new materials, but it could be applications of new materials, it could be any other topic that is of desire for those countries. So, this is supposed to have applications, but the materials that we created have many applications in hydrogen storage, methane storage, carbon capture and conversion, and this is the last one. This is water harvesting. Plus, the community out there, the scientific community, is working on a whole array of applications. So you can see that there is a truly large area of research that crosses chemistry, physics, biology, and engineering that has emerged by virtue of not just our inventions, but also the scientific community coming together to develop the field. So there's a lot of value in establishing these relationships that would be based on basic fundamental science, because basic fundamental science is where you learn how to discover. And that's where I think student and professor work together very closely. Because remember, the basic science or discovery is an arduous process that often the researcher is dealing with chaos, with dealing with an unplanned experiment, or I should not say unplanned experiment, but maybe planned experiment, but they are not following a blueprint. Okay, they're not doing incremental research, and so there's a lot. And what helps that process is the interaction with the professor. So by engaging with scholars in various countries, we also discover that people dream. Young scholars, regardless of how proficient they are in chemistry, they have dreams on what they want to do. And so maybe one of the dreams is to make a woven structure like this. Nobody has ever made something like this on the molecular level. If you could make something like that, it would be porous, robust, flexible, and resilient. There is no material that exists today that has these properties. So, so we've been able to engage on this basis with scientists all over the world in our centers. The chemistry, on a fundamental level, the chemistry is simple. And that's why many prepared and unprepared minds can engage, and the prepared ones can become very proficient, and the unprepared ones become prepared, and they are on their way to developing their skills on how to do research and how to grow a research culture in their own country without having to travel to do that. So we realized that, in fact, we're addressing three very important challenges that have, I'm sorry about this, this is the lesson you learn is never to give your slides to any other computer. So, but there are three. One, we discovered that there is a huge number of people in the world that want to improve, want to learn, but they don't have opportunity. And these centers that we created provide them to plug into research locally and develop their skills. The second thing is that there are only very few scientists in very few countries that are solving the world's problems. That doesn't make any sense. It should be that many scientists in many countries solving the world's problems. That then enhances the chances of solving the problems and enhances the chance of not having problems spread beyond where they are, where they exist. And of course, the uneven distribution of knowledge. Okay, sometimes we think by building borders around the things that we know that we enhance our position, but in fact we are not. Is that everybody stands to benefit if we distribute knowledge around the world and we work towards distribution of knowledge. So we formalized our approach, and we created the Berkeley Global Science Institute, which has a mission of partnering with institutions of learning, foundations, government, industry in the United States, and abroad to create, okay, now I'm all confused, okay, all right. But basically our mission is to work with various countries and create centers of research in those countries on topics that are of interest to those countries, but keeping in mind that we want to develop basic research all the way to applications, so that to ultimately address the needs of that country. But we believe that there are three things that we cannot escape from, and that make us very hopeful and make us work very hard for this mission. One is the resiliency of the individual. No matter where you are and where you're from, you really can overcome difficulties. This is what we believe, and this has been our experience. So the idea that it doesn't work, I don't have the resources to do it, doesn't exist in our language. In all the people we deal with, that's the very first thing that they learn, is that they have within them the power to overcome the challenge, and many of them do actually do that. The transformational nature of science. When you make a discovery, it changes the equation. It changes the platform from which you can address many different problems. That discovery changes things beyond your imagination. So with science, problems that you think were impossible to address, with one discovery, can change that completely. And now they are soluble problems. And that's why it's important to do the discovery. And we believe that one-on-one, unconditional giving is the key to innovations. And let me explain that. When we work with students, and a student comes into, let's say, my office, I drop everything and I work with that student. If I have a researcher from another country send me a paper and say, Professor, what are your thoughts on this paper? What do you think of the science? How do you think I can improve this paper? I drop everything and I just take 5-10 minutes of my time to read over this paper and make suggestions for improvement. That helps that researcher beyond measure. And so this one-on-one care is absolutely necessary, and it's a key feature of what we do. And I'm not kidding. Each one of the people that are sitting here who are related to the Global Science Institute is a result of the one-on-one mentoring. And we can talk more about that. Why is mentoring important? Because in the research-strong countries, each researcher has a mentoring tree. So let me see if I can... okay, is this a pointer? No, okay, yeah. So I'm here, and my cousins are here. Okay, some of them at Berkeley, some of them are in Texas. They're all over the world. And this is my advisor who worked with another one, with his mentor, and then he worked with Sir Geoffrey Wilkinson, who invented organometallic chemistry and won Nobel Prize in 1973. But the values of doing research are passed from one generation to the next. And now we are passing it over to Kyle and Felipe and Alejandro, who are present here. And they have students in their own countries that can pass that tradition on to. And then that means that every researcher we want every researcher to have a mentoring tree. And once you have these skills passed from one generation to the next, then you have the cycle of innovation that works. So when we engage with various countries, we have many things that have to come together to make sure that cooperation is successful. First, inclusivity. We do not want to exclude anyone from our institute. If you have the merit, you should be included. Mutual understanding. We write contracts with, together with our partners to make sure that everything is very clear and everything is understood. And also accessibility is that people need to have access to information, access to help, access to the laboratory, access to the center that we create. In some countries, we have to bus the researchers because it would take them a whole day to go from where they live to the city, to where the center might be. We also believe that the partnering country and our institute also both have something strong to offer. We do not have the idea that we only give something because we're the experts and we're the ones that know how to do science and the other partners don't. That is not a very productive way to think, and we don't think that way. We think that everybody has something important to offer, and that's the thing that we need to identify in that partnership. We build, if there is no infrastructure to do research, as we did in Vietnam, we build that infrastructure, we help them build that infrastructure. And sustainability, after you run the thing for a few years, you have to figure out, well, what happens in another 5 years? Did we develop a strong foundation? Is there an emerging leader from among the people that are in the center that could lead these centers? Funding is never a problem. No matter where you are, no matter which country it is, the minute we have these partnerships, money starts pouring in. Money is not the problem. So, but that's something that we also help together with partner jointly to provide funding. All the funding for these centers comes from the country where the center is created. And of course, we need to always be in contact with the government on both sides. On the partner, the two sides, we inform the government what we are doing. We incorporate them into our center so that they are aware of what we are doing. And also, if there are opportunities that arise, they can always inform us and we can capitalize on that. So using this kind of thing that I'm describing, we have been developing centers originally in Japan, and the purpose there was to mix researchers. So each country has a different motivation for engaging with us. Japan, that was for mixing researchers, excuse me. Korea, to have high impact research. Vietnam, they didn't have an infrastructure for research, so we together with them built that infrastructure. China, high impact research and engagement with top scientists. Saudi Arabia, building a functioning research infrastructure and high impact research. Jordan, we've been in discussion since 2012, and I'll show you our plans here. Spain has been an important part of this equation in that they have been a node that contributes to this endeavor by taking students and also offering their expertise to the various centers. We just opened a center in Indonesia and in Malaysia. Argentina, we already a center is in the works. We are already in discussions, and we submitted the paperwork and the grants for Turkey. Mexico is in the works. United Arab Emirates is in the works. Peru is in the works. And this is so popular that we have so many actually standing in line, like Kazakhstan and South Africa still to partner with. But the power of what we have developed is that, these are the nodes as triangles. These are actual collaborative centers that are very productive. And then the dots are experts who are willing to drop everything and go to these centers, give lectures, work with students, do one-on-one mentoring. They are hand-chosen so that they do share our vision and our our way of doing things. So Vietnam, which we launched in 2011, when we went there, they didn't even have a building. So we rented a building together with them and put the plumbing in, put the infrastructure in, wet laboratory, as we call it, to invent new materials. And here, you can see here, this is a wet laboratory you're all familiar with. Sophisticated instrumentation, IR, GC mass spec, X-ray, instruments that are really better than my own at Berkeley, okay? And the government paid, the Vietnamese government paid for all of that. They were delighted to have this collaboration. And the Vietnamese have a strong will to succeed. So we had 10 PhD students, and you can see here all the things that we have been doing. So look at all these journals. These are journals that no scientist in Vietnam published in these journals until we opened our center. So the cover of Angewandte Chemie, which is one of the leading journals in chemistry. And we hold different conferences and symposia. But really the main point is that Manar, or this center in Vietnam, inspired other research groups and centers to achieve promising scientific results. And that's really the secondary effect that you get. It's not just the people in the center that are directly placed in the center that benefit from this, but everybody else is looking, and everybody else is learning on how we are doing this, and they are inspired by it. Some are plugging into the center, some are developing their own initiatives. So the real power of this is that just for, let's say, the Vietnam node, you can see that there's a lot of exchange and a lot of human movement between our centers, so that they can, now we have someone that we mentored in Vietnam, Lak Ha, is in Saudi Arabia, helping with launching the center in Saudi Arabia, okay? He published several high-impact papers, and we have some that are going to Korea, some that are going to Spain and Milan, and so on and so forth. So there is a human network that benefits from this mentoring and passes the mentoring style onto future generation. In Jordan, we have the vision to launch this, what we call the reticular foundry, soon. We've been in discussion with Her Highness Princess Sumaya since 2012. And we recently signed an MOU with Berkeley and also a collaborative agreement. We intend to make it a node within our network, but also we see the reticular foundry, since this is going to be focused on making new materials and studying their applications, also providing samples to be studied in Sesame and other institutions in Jordan. We have a vision that this would be part of a larger global science initiative, King Abdullah II initiative. But in this center, we have the scientific program, we have people that make things, make new things, discover new things, people that measure, and a user facility that Jordanian scientists and scientists from the region can plug into. But also, we have another mission, and that is to popularize science in society, so that to enhance scientific literacy in society. This is what the building looks like by planners. And let me just say that I gave you the example of Vietnam, but every center that I pointed to is just as successful. And these are the things that we do. We work together with our partners to establish state-of-the-art research. We recruit also the research talent for these centers. We help prepare funding proposals. It turns out this is a great thing for industry to plug into. Many international Companies want talent from the local talent where they have, let's say, a branch to hire them. This turns out to be a point of contact for them to employ that talent. High impact publications, we connect scholars to the world scientific community, okay? We provide new opportunities for young scholars. We plant the seed of mentoring. Lakha example, going to Saudi Arabia. That's a seed that was planted in Vietnam, but now it's growing. And then, of course, using science as a language for peace and prosperity. So for those of you who want quantitative measures, just over the last 5 years, we have published 85, and all of them high-impact papers. Okay, the people involved in this, including me, we're not interested in low-impact papers, right? We're engaging because we want to improve the level. So 85 high-impact papers, papers that are as highest impact 40. We have held 15 or more workshops. We've mentored directly one-on-one over 200 scholars. And the scholars that have participated in various BGSI or Global Science Institute programs abroad, 300. And then if you just think about the secondary effect that I showed you, over 1,000 scholars have plugged into research. And without our efforts, they would not find a way to do research, at least not readily. So this provided them a venue to make their dreams come true. Okay, so you can learn more about what we are doing on this website. I guess the final point that I want to make is that I find that in all of the countries that I listed, there is so many hungry minds, and they are willing to work very, very hard, provided the opportunity. Okay, that, to me, that is quite inspiring, to me and my colleagues who are involved in this. And it also provides hope that we can globalize science like we globalize banking and commerce and transportation. Okay, so thank you very much.
Okay, thank you, Professor Yagi. I appreciate that. Nice laying down the foundation for our panel discussion. So next I'm going to call up Professor Dr. Pavel Kabat, who's going to talk about his Young Scientist Summer Program at IASA, and to provide further context for what we'll discuss shortly thereafter. So, welcome.
Yes, very good morning, everyone. When Her Excellency Royal Highness Princess Umaya visited IASA last summer, we had a lot of very hopeful conversations. And one of the conversations was with our students, with our summer students. And the idea was born immediately. Why don't we connect to yet another center of excellent thinking, which is the Berkeley Global Science Institute? So only last June, end of June, we agreed to come here together. We are standing here proudly as a partner of you, Omar, and your group. We have brought together 6 brilliant minds to here, 3 from Global Science Institute and 3 from IASA ISSP. You see, we were kind of not planning. We have 3 brilliant men, 3 brilliant women here, and we are going to talk about future. I'm going to talk about innovations through transboundary system thinking. Let me just say a few words before I start. Omar gave you excellent, really excellent pitch to be good, to be best, to be inclusive in your discipline, in your science. This is absolutely fundamental. And I think he couldn't do a better job than he did. What I'm going to challenge you into is, when you are good enough in your scientific discipline, try to be open and open up the borders to other disciplines. Because in the end, we talk about systems. We talk about systems where the chemistry and physics and economy need to come together to understand the global transformation. We talk about horizontality in collaboration between different disciplines. We talk about linking physical, natural, and social sciences together. This is what we call system thinking. Now, what you need to do, and I'll see if I can operate the system the way how it should go. Probably I can. What do you need to do to change the world? You are all young here, and specifically this panel. This is the world, how it looked like only less than 50 years ago, late 60s, early 70s. This is the world which was called East and West. We had a huge divides. We had a possibility of Third World War because of the nuclear mount armament. We had a first oil crisis. What do you do when you are facing such a situation? What do you do, by the way, where such a situation is being faced now again? What do you do as a young scientist, as someone who wants to change the world by your knowledge, by your inclusion, by your collaboration? Well, you need three things. You need a courage, you need a vision, and you need a leadership. This is what happened in 1967, where these two great world leaders, former US President Lyndon Johnson and former Prime Minister of Soviet Union, Alexei Kosygin, met at Glassboro to talk about building bridge. As they have talked about many bridges, including science. Science should be a bridge. And they decided to establish an institute, and I'm going to read it, convinced that science and technology, if wisely directed, can benefit all mankind, believing that international cooperation between nation institutes promotes cooperation between nations, and so the economic and social progress of peoples, hereby resolved to establish YASA. It was 12 founding member nations who came together at that time. It were scientific competencies, as Omar put it, which brought the first club together. Mathematics of advanced system analysis, mathematics and physics of air quality, ecosystem services, forestry, agriculture, food security, energy system transition, evolution and ecology, risk and resilience, transition to new technologies, so important, water, demography of our populations. These were scientific disciplines which YASA still cherishes as its fundamental ground. It started indeed as an East and West Global Institute within 12 national member organizations, 12 founding countries, led by United States at that time, USSR, Japan, and the remaining 9 came half from the former East, half from the former West. The Cold War started to fall. This is a historical picture from Iceland, Reykjavik, where Mr. Gorbachev met with President Reagan and agreed to thaw the Cold War. Today, the focus of YASA is global. We are truly global, international, independent science and science to policy institute, having 24 and very soon 25 member countries, 450 international staff from 50 countries in host country Austria, about 3,000 affiliated scholars and science policy diplomats worldwide, 600 plus partner institutions, 200 visitors, 2,000 visitors annually. We are trying to look into the challenge of the global nature. Now let me go back to the need for building bridges. Remember my picture showing 1970, showing the Berlin Wall, showing the divide which science could help to bridge? This is the current world. We are going to the fragmentation again. We are speaking about needs for bridges to build multiple divides, equity, equality divide, digital divide, technology divide, educational divide, but also, unfortunately, new geopolitical divide. What is system science doing about it? What is this paradigm of putting together disciplines, nations, transboundary doing? It's employing international, integrated, interdisciplinary, solution-oriented scientific approach. This is what we call system analysis. In terms of people, yes, we are attracting the best researchers worldwide. You see here 5 or 6 Nobelists connected to the Institute over the last 45 years, Nobel Prizes. But equally important, and even more important, we are engaging with the best researchers of tomorrow. You see them here. because as Omar put it well eloquently, this is where the most of the focus should be. From the one-to-one mentoring, which I only subscribe to, Omar, very much, all the way up to creating a community, peers, which can stimulate each other, which can work together, which can stick together. So, in 1977 already, YASA established a global school called Young Scientist Summer Program. Every year in summer, for 3 full months, about 50 selected participants from thousands of applications come to YASA to spend, yes, 1-to-1 3 months at YASA, coming with their PhDs, which are usually half through, and having one important objective, to finish their 3-month study at YASA, not only by project, but by paper to be published in a high-standing journal. We are proud to say that since 1977, almost 2,000 participants came to YASA to do this. And most of them stick together. Most of them became influential scientists, either academics. Some of them became science advisors to chiefs of the governments. Some of them became even academic presidents. You see 3 of the alumni here behind this table. So YSSP is our worldwide network of scholars who stay affiliated with us since first moment when they came to YASA until their career is over and even beyond. As I mentioned, it is advanced PhD student focus school on all these possible subjects we are doing. It is a very intense supervision, collaboration, and it doesn't end after they leave YASA. Most of them become part of the YASA system. They stay collaborating with the researchers across the world, not only with their supervisor, but with this network of thousands and thousands of researchers, pretty much like Omar put it from the Berkeley School Global Institute. And they have a big chance to win a number of awards to come back, like, for example, these 2 awards for our postdocs then. Now I'm going to make some propaganda here. It starts 1st of June until August. We have applications coming for the next generation, which is open now. I hope that you will help me to distribute the award. I hope that some of you will apply to this program because it can be run until January 2018. I could stop here because I promised to be brief, but I won't. I have a little apropos here, because many of you are young and eager and our future. This apropos is here. You know, whatever we do in our scientific things, we should realize that we have entered a new geological era. We call it Anthropocene. Paul Cruzen and I made a published paper in Science some years ago illustrating that the footprint of humans, of us, on the Earth system is attributable to human activities as compared to some of the geological eras then. However, are we really Homo sapiens or Homo not so much sapiens? Are we really able to deal with Anthropocene? Well, the current evidence says that we may be not really that much sapiens. We are overusing resources. We are overusing the capacity of the Earth, both in the social and natural systems. Can we build a future on the old paradigms, even in science? Can we close our eyes to the big challenges which are, for example, connected about the sustainable transformations to the world? The fact is that we should not. And I started with a vision which led to my institute and to this wonderful network around the world. I am calling for vision here again about how to face this challenge of interconnectivity, of scientific transformations. I'm using his Seneca, who said if one doesn't know to which part of the world he's saying no wind is favorable. We see it everywhere. We see it with the governments, we see it with your academics, we see it with your incentives. So pretty much like this big thinker, this big example of many of you, Sir Isaac Newton, came with this Renaissance vision. There is this print of his Principia Naturalis Mathematica. We need very much Anthropocene vision. And I do hope that you, young friends here, and your colleagues across the table will end up in this picture, because at this moment we don't have such a vision as yet. Thank you so much, and I hope to welcome you very soon at YASA.
Thank you, Dr. Pavel. Okay, so I'd like to introduce our panel today. So we're going to spend the last, I think, 15 or 45 minutes hearing from the young emerging scholars. I shouldn't say young, but I should just say emerging scholars. So I'm going to ask them to introduce themselves briefly, and then we'll try to start a dialogue, a discussion, make it lively. And we'd love to hear from the audience about questions based on what we talk about here. So I'll start with Anha.
Thank you, Kyle, and good morning, everyone. My name is An Ha Chung. I'm from Vietnam, and I'm a PhD student, also a researcher in Vietnam Academy of Science and Technology. And I am a YSP in YASA just 3 months ago.
Let me just pause right there. Let's hear about your background and your achievements. What challenges you faced in your career? Yeah, sure.
Okay, so I'm a PhD in energy economics, and I would like to share a bit about, or from my own experience, about what would be needed for young emerging scholars to participate in the global mentorship, what needed for young scientists. So I think there are 4 elements. First is the network, to bring the young scientists opportunities to participate, and then the capability of the young scientists, and the resources, and the last thing is like the young scientists need to overcome like personal barriers. So I'm a woman, and I'm a mother also of a 5-year-old girl. I'm from a developing country with quite traditional cultures, and with a relatively small science community trying to like reach to the world. So of course, just like for others, young scientists like myself, we are facing a lot of challenges to be able to be a part of the global science community. So my first step to go toward global science community was to enroll in international university for master, and then for PhD degree. It was quite an unusual decision for women in Vietnam who have a similar social background, but I was kind of supported from my family. There in that international university, I built my network, and from that network, I had the opportunity to go to YASA for YSP summer program. So that's how the networkings are really important for young scientists to be able to approach the opportunities, to seek the opportunity. But to be able to grab the opportunity, you have to prepare yourself for that. So you have to build your own capability. Of course, besides of scientific or research skills, young scientists, I think they also need language skill, very important. It's to be able to communicate with the world, and also the cultural sensitivities. So the cultural sensitivities help you to be able to understand better the differences, to respect the differences, and to be able to fit in the world with a lot of differences, and to treasure it, and to get benefit from it. Another very important point is that you have to have the resource, like the funding, the facility, the infrastructure is needed to conduct high quality scientific research. And in my case, through my 3 months in YASA, I was so lucky to be funded by YASA to be participated in that summer program. And in YASA, they provided us not only the infrastructures like high performance computer for my optimization, programming, also the software like ArcGIS or GAMS that I couldn't have the license in Vietnam, for example, in my university. Also, they have the library, well, we can access to the library. And And they also organize all the workshop and help us to organize our own workshop to build our network and to build our own capability. My last point is that every young scientist had their own personal challenges that they need to overcome. And for my case, the balance between family and science. So what I'm trying to do is trying to talk to my family, to also to myself, that reminding myself that the meaning of the work that I'm doing. So I'm telling my husband, like, hey, I'm doing science, I'm saving the planet for our daughter, for our grandchildren to have a better future. Well, so I think the last point is that for young scientists is important to first to build your capability, and then second to try to reach out to the world.
Okay. Thank you, Anha. And I guess we can clap. Why not? Okay, next is Nemi, also from IASA.
Hi everyone, I'm Nemi Bora. So I'm an Indian citizen, but I study in the United States. I'm from a small town called Pittsburgh in US, and I am a PhD student in engineering at University of Pittsburgh. So unlike Anha, I don't really have like family engagements. Like I'm a run-of-the-mill PhD student, always working. But what I liked about Dr. Yagi's talk and Dr. Cabot's talk was like one-on-one mentorship. And what YASA provided us was this interdisciplinary mentorship. So like as an engineers, we tend to talk to engineers, publish in engineering journals, and attend engineering conferences. And that's important because those enable us to provide robust solutions to whatever problem you're looking at. But at the same time, you need a different perspective. You need a chemist's perspective to how to solve the water challenge. You need a social scientist to ask you, what are you doing for consumers, for other social classes? And once you start asking these questions, you start building a story, hopefully publish it in Science one day, but you start looking at a systems level perspective, and that's where YASA came in, providing this interdisciplinary background and giving us this opportunity to look at a same problem, a same boring engineering problem, but with different perspectives and trying to create a story out of it that was policy relevant. Thank you.
And next is Bassem Al-Maithaloni.
I'm Bassem Al-Maithaloni. I'm a researcher at King Fahd University of Petroleum and Minerals in Saudi Arabia. I did my bachelor and master's in Jordan, and I finished my PhD in Saudi Arabia. I were lucky in Saudi Arabia to blog with Professor Mohammed Al-Dawoodi, who's Professor Yagi's student, and there I learned how to make good research. Actually, and we published JACs and patent, high quality research. So then I get the chance again to go back to my mother university, which is King Fahd University, and to start my group work. But at that place, the mentality of high impact work is, or the quality is a little bit different. So it was very hard to convince the people that we need a lot of time and resources and training to have high impact work. Then I found that I were lucky again that I found that there is some mentorship provided by the Berkeley Global Institute to KFUPM. So I plugged again to that system, and I benefit from that opportunity that helped me a lot, actually, to start my career and to make and to convince the people also about the importance and the mechanism of building high research and high impact research. And at the end, we were successful to get a high impact paper that's completely done at KFUPM and by using KFUPM expertise. And that's also polished by the global collaboration with the global Berkeley Global Institute of Berkeley Global Institute. So We benefit from that. We utilize that opportunity to the maximum. And still we are using that opportunity, and we are hoping for another high impact. And this little bit, I think that it start to change mentality toward high impact, because they now start to see the fruits of that collaboration and high impact work. And now on, I think we have another running system with very good expertise in this field, and we are building a state-of-the-art lab. And still we are always, we need some support from Berkeley Global Institute. And for example, we are submitting single crystal samples. Still we are buying some other devices, but at least we are on the track. And I hope that we will continue, and by also we may start to have networking with Jordan University of Jordan, and some other institute in Jordan to have to transfer also our experiences to Jordan also as well, because it's my mother country. And this is my story, and thank you.
Okay, Alejandro Fraccaroli.
Good morning, everyone, and thank you for being here. Please allow me to acknowledge also the organizing committee for giving us the chance to be here and speak about our experiences that hopefully will help also other young students or scientists in this case to have another experience like ours as well. So I am now an assistant professor at National University of Cordoba in Argentina. But around 10 years ago, I was a student. I was a PhD student. I was finishing my PhD. And like many other students in Argentina, I was looking abroad, and I was watching that other people were solving global problems. I was curious, and I wanted to solve the same problem. So as many other students in Argentina, I started to apply for postdoctoral positions. And I contacted Professor Omar Yagi, my global mentor here. And he offered me a possibility that I never thought about. So he didn't have space in his lab in UCLA, but he offered me with the possibility of going to Japan to do a postdoc there. And that was a global science institute at that time. So I decided to take the challenge, although it wasn't my first thought when I was thinking on my postdoc, but I decided to go there and experience this way of doing science and solving global problems. So that experience was actually very enriching, much more than what I thought it would be, because we may have some goals when we are young and we are finishing our PhD, but so I find that there is so much more out there that we don't know, and it will be very important to learn as well. So I faced a completely new way of doing science, a completely new topic to challenge. I learned chemistry that wasn't available or wasn't being researched in Argentina. So that was very valuable for my career afterwards. Then I moved to Berkeley, and I was mentored by Professor Yagi on this one-on-one system. So I completed my education, and I could see how fruitful it could be to have people from all over the world teaching you and also learning how to do science in different countries and what are the real global challenges that we all need to address together. So that experience was kind of unique. So I'm now back in my home country. I'm trying to train students. I am trying to be a global mentor for other abroad students as well to complete this cycle of innovation. So I think that this is a very important part and very important opportunity for people from all over the world to do science on things that really matter, and also to collaborate and communicate in the same language, which is science. So I don't want to be too long here, but this experience, I hope it will be helpful also for other young talents and scientists here in the audience and also in other countries as well. So thank you very much.
And then Karen.
Good afternoon, everyone. My name is Karen, and I come from Israel, and it's a little bit funny because Jordan and Israel are neighbors. The flight literally takes 20 minutes. In general, it's more or less like 45. We are so close, and still sometimes I feel that we are worlds apart. And I'm very happy to be here. This is my first time in Jordan, and I have received the warmest welcome I could have ever imagined. And it's like Professor Kabat has pointed out, we are building bridges between nations, between organizations, between different communities, and I'm very happy to be part of this bridge. I'm a PhD student at Tel Aviv University, and I'm probably the only one who is a social scientist here at this panel. So I am not in a lab. I study people and their behavior. And the main point of my dissertation that I'm writing is the rise of the new radical right in Europe and in European countries and among European societies. I would say that the world we live in has become not only global, but also local. We have so many problems at the local level, and we have so many challenges at the global level. And I think to tackle all these problems and all these challenges, in order to tackle them, we should share our experience. We should share our personal local experiences on the country level and see if any other country could benefit from these experiences. Sometimes I feel that we live in an attention deficit era when no one is focused on nothing, and sometimes, unfortunately, people are more motivated to speak than to listen. And that's why I'm eager to hear your questions and answer as far as everyone over here is concerned. So I really think that learning and hearing from other people's expertise is the key to success in this era. Thank you.
Good morning, everyone. So my name is Felipe Gander. I'm coming from Madrid, from the Spanish National Research Council. I'm a researcher. Well, first of all, I'm really happy to be here and thankful to the organization for giving us the opportunity to talk. And today I just want to be brief and go quickly to some of the points that we have heard already. And I'd like to illustrate with my personal experience how these points have impacted my life and my career. Starting from some of the points like mentorship, how it has been important. When I was starting my PhD, I had the luck of being working on a small group with where I was basically interacting on a daily basis, having a lot of chats with my supervisors, building a personal relationship, and to me that was very important because as Professor Jag was saying at the beginning, we now as scientists are part of a family tree. So now I'm lucky to say that I have a personal family and also have my scientific family, which many times they are in the same level. So that helps you a lot to build your personality and to see things with a different perspective. And highly related to this is the concept of diversity. And that I learned it when after completing my PhD, I moved to the United States. And at the beginning, I was just surprised of how many different people were working together in the lab. There were people at that point that we were coming from almost every continent. And there were people from Asia, Europe, from Australia, of course, from the United States. And that basically enlarged your way of looking at things, looking at different angles of the problem, because first of all, you cannot work alone in a lab. You have to work with many other colleagues. You have to learn from them. You have to teach them also. But you need to learn, first of all, how to interact with them. So we all have different cultures. We behave differently, but at the end, we have one shared common, which is solving our problems in science. And that's very important to me. And again, I think that's basically one of the parts that help to build your career and also your personality. That is very important. And the third point that I like to stress is how important is after building this mentorship, mentor-mentee relationship, and be dealing with the people from different cultures. How important is to transmit the knowledge and to be able to teach and to learn from others. So I had the opportunity to build an expertise during my PhD in an area of chemistry and in crystallography. And then when I moved to the United States, I was facing very complicated problems, so I was also lucky to be able to build this expertise even more, to work with other students and researchers. And by the time I went back to Europe and to Spain, I started to work in my lab. It was clear to me that now I had another responsibility, which is to transmit the knowledge. And to work to transmit this knowledge, not only at the local level with the researchers that are in Madrid, but also with other groups coming from other countries. I had the chance to work with the students in the group in Vietnam, inviting them to be in the lab and to learn that part of that knowledge that I had acquired in the past. So I think that's an important part of the science, which is this transmission of knowledge, or the concept that we heard in the first day, like this intellectual generosity that we all should have to help people everywhere, really to enrich their minds and help them in their careers and also in their personal life. So thank you very much.
Okay, I'm going to open it up for questions. I have plenty of questions to ask, but if it would be great if the audience could. Okay. So yes, I don't know if we have a microphone. Yes, sir. Yes. You're raising your hand, right? Yeah. So Alejandro or Felipe, you want to tackle that one? That's a great question.
Yeah, it's a very good question. Thank you. So you're totally right. The challenge you face when you come back to your country are also very important, right? So you have ideas when you start your career, and then you have an experience that changed your life, like a postdoc, for example, in my case. But then you come back to your country and you realize that there are other challenges that you have to face. But I guess there are two types of challenges. So one part of it is that we have intellectual challenge and also global problems that we have to solve as a scientist. So that was the part that we were talking about mainly. When we are talking about scientific problems, I think we have a lot of them in common with Berkeley. And the way of solving them, it's also a common way. So you have to address those challenges in a scientific way. So learning how to do high-level science, it's very important because it's a common language. So if I do science in a different way in Argentina, then that science will not help other scientists in the world. So that part is common. I think that the practical challenges that we face locally are different. The reality we have in Argentina is completely different to the reality in Berkeley, that's for sure. But then at least I know what kind of things I will need to do this kind of science to solve the challenge. So what I have learned in Berkeley is essentially a way of solving the global challenges and also a way of transmitting this procedure or this part of the science to young people. So this one-to-one mentoring is something I learned through my experience in Berkeley, and I can use that to teach people in Argentina. So that is something that is independent on the local challenges, right? So then there is a question of funding. I think that something was said in the panel already. So having a contact with a global network helps you to attract funding, because the people now believe that we are working together to solve problems that are of interest of all countries. So in my personal experience, it has been successful so far. So I can tell you that writing a proposal in collaboration with other countries, and I'm not talking about Berkeley only, so I'm talking about Spain or Jordan, so that helps a lot, because then the people reads your proposal in a different way. So they say, well, okay, there are people from different countries that want to solve a common problem, and that can be enriching for the country, right? So that's what I can say so far about the experience I have, which is not much, but I hope it helps. Thank you.
Yeah.
I just want to add to that great answer that Alejandro gave. I just want to emphasize that what we're doing is really emphasizing the one-on-one contact. When a professor or an expert sits down with a student who's willing to improve and have this one-on-one interaction where they're working on a problem, let's say writing a paper, they just had a result, they discussed the analysis of that result, and they're trying to summarize that in a paper. For them to be sitting there talking about how this should be organized and debating this point, immediately you realize that there is a transformation there, that the professor and the student are equal. My students talk to me as equal, and they contradict me freely. When I'm wrong, they'll say, Professor, you're wrong. And when I'm right, they don't say that I'm right, but they go on. But the point is that once you do this, it's a transformative experience for them, because now I've given everything I know to them unconditionally, knowing well that one day they will be out there competing with me, but yet I'm giving unconditionally. And this makes a bond between the professor and the student that is never broken. This is what we really need to do. This is what we are doing in the Global Science Institute, but we would like to spread this all over the world. I mean, how many professors do we know work with their students on every single problem in great detail as I'm describing? That's not easy. That's hard work. We're all very busy. But what I'm trying to say is that the student is #1 priority. And that's the value that we have in the Global Science Institute.
Thank you so much. Dr. Amar, congratulations, really, not only for the science and the innovative discoveries of the new material, but for the Institute and the way you engage one-to-one mentoring. Really impressive. And this is the second time I hear you give that overview. And as a faculty member, it's always the hardest thing is to get that knowledge transferred to one-on-one. My question is regarding your experiences on the emerging laboratories, whether it's in Saudi Arabia, maybe future United Arab Emirates, in Jordan. You know, in science and you working with the labs requires a lot of hours and intense hard work. And the cultures tend to be here, from my experience when I came to Jordan, that by 4 o'clock, nobody on campus, nobody in the lab. And the culture of hard work and to really come up with innovative discovery is not that, matter of funding and infrastructure. I think your circular development process makes sense. I have the funding, I give them the equipment, I have the building. I want the faculty, the students to come to the lab and stay all day, and then the weekend, and then they worry about the science, why it's not working, do you see that changing from your interaction? Are those countries are trying to catch up and get those faculty and students in the lab?
Yeah. Oh, yeah.
Can I just say before Professor Yagi speaks, I think it starts with the mentor themselves. If the mentor is going to change the culture of work, I'm currently in Saudi Arabia, and it's the same sort of situation. And I think you have to put in the long hours so that they're looking and modeling their own work after you. That's a big component of what we do. Sorry, I just wanted to interject.
Yeah, I mean, I just want to say I don't really pay too much attention to how long people work in the lab. But what I do pay attention to is the quality of the time that they are spending in the lab. To make a discovery, You can't leave the student in the lab like a goat grazing in the wilderness, okay? You need to have enough interaction with them without being overbearing. Okay, that requires time on your part. But when they know, when they see that you're interested, they're working hard, regardless of who they are. They're working hard because they are there, because they want to make a discovery so that they can write a paper, so that they can graduate, so that they can get a job, so that they can improve their life. That is consistent across board. That's what all students want to do. And of course, what the professors want to do, they want to break new areas of research. And so those two things meet when the student is there making their discoveries. The professors can't be too far behind, because although the student is picking those observations that are going to make a difference, the professor has to be there to make sure that they are analyzing them properly and that they don't miss something very important, right? That's mentoring. We are throwing them there in the world of chaos. Okay, the world where there's no blueprint for discoveries. And so the professor has to be there to make sure that they learn how to solve problems in this chaotic environment. Once they know how to do that, you've created someone that thinks independently. And they are equipped for life to attack challenging problems. This is really what we do on the detailed level. Now, whether that will change the entire culture of research in a country, maybe one discovery would be a evidence of great success, and maybe people start looking up to it.
Yeah. Well,
But I am working with the people in the trenches, okay? Because I believe in the power of the individual. When we wait for governments, the state, whatever, to provide us with the environment, it never comes. Because the individual is the most capable, okay? That's,
okay. Let's let Karen wanted to say something as well.
I just wanted to add that as a YASA participant during this summer, I think I saw no one leaving at 4. We kind of stayed till 6, and sometimes I remember myself staying till 8 o'clock in the evening just to finish this part of the research. And I think that I met 50 wonderful, dedicated young researchers who were so dedicated, and they wanted to see their research progressing, and they were all in for it. So if you have any problems with 4 o'clock leaving, just send them to YASA. They will know the new discipline.
Okay, I'm going to move to Dr. Hanan.
In fact, I really, I was inspired, but what you both, Professor Umar and Professor Kabat, and these young stars, our future, were talking and showing. This pedigree, the family tree that you showed, Umar, مع حفظ الألقاب طبعا, it's fascinating. I think if everybody follows what you are doing, it's not proposal, it's real. Because all what I have been hearing since these 3 days is we will, you are showing a true case success stories. Though I have a question, in fact. I don't know if these young researchers from all over countries, and by the way, I like the interdisciplinary approach. It's not just chemistry, we have social scientists, and this is the true science. You cannot exclude any specialty. Now, do you guys mingle between each other? I mean, it's not just in your own country. What about Felipe and, I forgot the names, but because it has to be also interconnected. And the other thing, question, this pedigree, I was waiting to see the seats below the university students, school kids. Is there branches below this tree? because these are really the core stones that should be educated with this innovative approach that you are following. Thank you.
Thank you, Dr. Hanan. I think that's a great question. Let's first turn to Alejandro and Felipe about, do you interact with other people in the Global Science Network? How do you do that? And what are the benefits?
Yeah, so yeah, it's a great question. Okay, no, yeah, you can hear me now. So yes, indeed. I mean, this is one of the great things of the network, of the Global Science Network, is that we are actually in contact with them, and that also correlates to the other questions on how we tackle problems that we find. Is that we also learn from each other how to face these problems, and yeah, we're constantly interacting. Say for trying to attract funding, to also to exchange students. That's something that is happening on a day-to-day. And on the second part of the question, we are also transmitting this way of thinking or learning of doing science to new generations, indeed. So I also learned that from Omar, how important it is to sit with the student, and when you are doing this summarizing of results, how important it is to go word by word on the writing and learn from each other on how to improve. And I try to transmit that because I think that's something that really impacted on my career, on my way of growing as a scientist. I think it's important to do on the next level.
If I can just comment real quickly. I think Felipe, Alejandro, Bassam, and I we're all together in Professor Yagi's group. And so we're all the mentees, if you will. And now as they've grown up in their career and they've established their own independent group, we've turned into cousins and we've turned into collaborators, where I rely on Felipe to collaborate and work with our Vietnamese students on solving their crystal structures. And same with Alejandro. He's plugging into the Global Science Network. So the cousin relationship of that family tree has continued beyond when we were just students in Omar's lab. This is kind of the power of it. Yeah. I'll let Nemi.
Maybe first the young generation.
Oh, okay.
So I would just like to say it from a student's perspective, because now you guys are professors, but like we're still students. So I think it's really important to still be connected to another student, because like you say, these are the people who are in the trenches, working in the lab, working with the data and getting their hands dirty. So the first part, like when you're analyzing the results, you need your advisor. But when you're trying to find the right method, the right data, you need another student. And that's where we connect. Just calling up a friend, like, hey, there's this model you worked in Vietnam, and what are the assumptions you made? And can I make those assumptions for United States? So that's like having your local issues, trying to plug it in your own problem. So like we're all on like Twitter, Facebook. Our Chinese friends are on WeChat because that's what works there. And so yeah, just talking is really important, and not with just with your mentors, but also with students. Yeah. That's it.
Okay. Well, just 2 comments I would like to add to this conversation. Besides of IASA, I'm also a professor of system science, and I have been doing mathematics and physics and other things. I have tens of PhD students across the world. And just adding to this conversation, sometimes we are joking, when you have a PhD student and when she or he goes, it's like a leaving child to the very angry big world. And this stays for the whole life. Whole life you are feeling connected to the student. I'm saying now what's happening to me as I speak. Just last weekend we had a recommendations letter to be sent someone who was becoming professor in Canada as an example then. You are proud of it. You are proud of it. You care on outside. You keep caring until they develop further. Yes, you are creating your competitors, you know it, but that's the part of your trust in each other. That's a part of your collaboration. And I think this is very, very important. However, we should not idealize the world. Academic world is a hard world with a lot of bumps, a lot of walls, a lot of competition. And I think this is something which needs to be also said. I think us, like Professor Ariel and I, we should be also giving to our students enough trust in us that we could help them to go through this very bumpy situation which we are now facing. The academic enterprise, in my view, is in crisis because the incentives are not right anymore. The incentives, as you said, are not ready-made. They are bound to many of the political and other strategic reasons, and this is something which needs to be also part of the structure. So, for example, what we are now putting together, and I hope that after this meeting Berkeley will join us, we are putting together so-called Global School of Excellence, where the young scholars at the level of PhD students or tenure trackers across the world, in 25 YASA member countries from the best universities, US up to 5, will mount on a 5-year program where all the disciplines from chemistry to physics, from physics to even theology, we have theologists in our YASA system, would mount on the 5-year program where they would be supported at their own institution, Stanford, Berkeley, Princeton in the United States, for example, to mount on the tenure track. They will get 2 postdocs, so PhD students. They can do their research inside of their own university. They are connected through electronic means, but they have to come together every single year for 1 month to do a joint thinking, kind of mini YSSP. This is something we are now trying very hard. It's a lot of bumps, but I think we will succeed, we will prevail. So in the end, this global school of excellence could be created. And I think this is one of the examples how we can cherish and further put it more organically into the place.
Thank you. We have a question back here, and then.
Yeah, thank you very much. My name is Mohamedou Ka. I'm from the Gambia, but I work in Nigeria. I am very fascinated with the work that you guys are doing, which is very, very important. I'm wondering what insights you have to help and facilitate more nodes and presence in the continent of Africa. When I look at your footprint, you are in the south and in the north, but majority of Africa is nowhere to be found. And it is one of the continents that cannot be neglected in the global science endeavors. I'm wondering what challenges that you face that might explain the dearth of non-existence. And I'm wondering what can you do with the limited scientists that exist in other parts of Africa. Majority of Africa's scientists have left the continent and the universities are deserted. You have talented young minds who are lack of supervision and exposure. So I'm wondering your insights, what you can do to help some of the folks that are back trying to help to address this matter. Thank you.
I'm going to take floor again briefly, just to give you an example. Little story, which is a true story. I arrived only yesterday because I had to be at a meeting, and this morning I met a woman, one of the women I respect, except for my wife, of course, most across the world. She's, her name is Naledi Pandor. She's the Science Minister of South Africa. Let me tell you why. When I came to YASA as the Director General in 2012, South Africa is a member, and I was taken to the corner by the South African rep on YASA Council, said, Pavel, help me. How can we get through this application, thousands of, we will get maybe 1 scholar to YASA system a year. This is not enough. Why don't we organize this school, this VICESP in South Africa? So we did. Naledi Pandor supported 3 years of program where the South African system became a hotspot of 3 months school, the way we describe it, across the world. We succeeded. Not only that, after this, Naledi Pandor decided to fund 9-year program where every 3 years, every year we will have a cohort of 30 PhDs coming from South Africa and Africa, supported by South African means, to do PhD study in the joint supervision between YASA and South African system. I think this is fantastic. This is a story which is true. What I believe is 3 things. First, you are right. The biggest untapped potential is in Africa. Talent is enormous. It's almost emotionally enormous. Second, we need vision. My vision again. We need visionary people like Naledi Pandor to help us to come through the system. Third, we need inclusion. We need to do exactly what my friend Omar said. We need to respect our students from Africa to be colleagues and partners. I think the old paradigm to come there to teach is over. We should come there to learn, to build partnerships. And I think when we have these three things together, visionary like Nalandi Pandora, come there to find a way through the system, and be inclusive partners rather than mentors, I think we will succeed.
Just a quick comment about the Global Science Institute and our engagement with countries. I must say that those countries were not picked by me, except for Jordan. I was really excited about our engagement with Jordan, but almost including Jordan, they've come to us. They've come to me. Vietnam came to me because I had a Vietnamese student, and they contacted that student. And so it is not a systematic thing that we do and say and pursue. It's actually coming from the outside, asking us to help in establishing. But also we look, we make sure that the engagement is going to be successful. That's another thing that you know. So the way these things happen is more ad hoc and by chance. Like in a meeting like this, I would get somebody afterwards who is really, really enthusiastic and has influence within their institution, and they say, you know, we would love to engage in this way. Then we pursue that. So, but I think that our institute is mature enough that now we can target countries and try to find through their academies or through the international academies, people that can be our anchor in that country and can help us establish. But I agree with you, it's on our agenda to establish centers in Africa. Yeah.
Okay, I think we'll take one final question. Okay, we'll do three. We got time.
Thank you all. First of all, this is Kawthar Hamad from Jordan. Thank you for the presentations and for the students and for the panelists. Actually, I want to mention two notes and ask a question. First, I believe that one-on-one unconditional giving is in one way or another similar to the 80-20 way of, we know that when I do one-on-one, that is when I receive a student who wants me to help him in something, maybe I pay 20% of the effort that I will, on the other hand, if I did not help him that time and wait for the time to go, maybe I will have to pay 80% of the effort later time that is equal to the 20% at the same time when a student comes to me. By this I mean that if I give everything I face on its time, what it needs, this will be easier than doing efforts later on for the same thing. My next point is, I like the point that you said, Dr. Omar, about that there are always researchers all over the world who do not have a way to go through. So this is a true thing that you may find in all areas of the world, researchers who just want a chance to get in order to be able to have output. I have a question about the outreach between the academy and the profession or the professionalism, and which one do you think leads the other between the academy and the professionalism? Thank you.
I think you know my answer. I truly believe in the power of the individual, the researcher. When I was a student, there was very little research being done in Jordan. There were very few instruments. There was no internet. But now, look at Jordan. The sophisticated instruments in my lab are found in Jordan. And I'm sure you can say the same thing for some other basic science fields. Internet. I won't say which country, but we went in there and Kyle interacted with one of their students, and I said to both of them, build a lab. Build a lab so that you can do research in the particular area that we decided together with the host country to do. Well, they spent 2 weeks together, and then Kyle had to go back to Berkeley. But what I noticed they were doing is that they were communicating, still talking. This is very powerful. This is a point that was just made by one of the young scholars. This is very powerful. This was not available before. So you don't have to be body there. You can be present through these interactions. They are very powerful, and they should be utilized more and more for this purpose. So I believe in the power of the individual. And then when the individual shines, other individuals shine, and very soon you have a system that begins to function, because where are these people going to go? They're going to become part of the larger system.
Thank you, my friend. I mean, I agree, but, you know, to be honest, it's a struggle. Let me give you an example, right? In Netherlands, where I'm not from Austria, we have a system where the education has grown enormously. The bachelor class could be hundreds of students. And I have a choice to go to my laboratory with 5 top talent, which I of course do, and forget about the rest, or to steal some time and go to speak to the bachelor students. And I think we need to do both, because as somebody said here, system has to grow from the roots. Beyond the bachelor, by the way, I think we also should find time, go to schools, to talk to teachers, because the culture needs to be nurtured from very beginning. So I try to talk to bachelor students. I try to give a lectures, because I believe that despite of all the technology we have, when people like Dr. Omar comes there, shows his patience, shows his face, this is lasting. This is lasting, and it's a seed to the culture, nurturing of the culture. So it's a daily struggle to find a balance between the excellence, focus on the excellence, and to be helpful, to be trustful, to be hopeful that you could create a culture within the larger mass. Right.
Thank you. I think we're going to have one last question here. Did you have a question? Okay. We'll do one last question, and then if you have extra questions, you can come up and talk afterwards. I think we're running over a little.
Eminent speakers, thank you so much for the lovely talks that you had. But I think one of the aspects that we need to acknowledge and take into considerations, I think sometimes you have problematic issues. For instance, I came from Germany, I finished my PhD in 2014. When I wanted to order, my major is in chemistry, and when I wanted to order a certain material, I order it today, I receive it by tomorrow. In Jordan, I had finished my master's. And this is what I talk about in developing countries as well. They might have the same problem. Some of my materials received after 6 months. You were saying, Karen, that you have 20 minutes being apart from each other. But to be honest, let me say it like that, sometimes technical issues are spoken. And Prince Al Hassan, in his first day, talked about such thing, technikion, and the way of communicating, how to transfer knowledge into Jordan. It was a bit a miscommunication. My question is, in such obstacles, how can I solve such a problem? Do I have to work on the chemistry that I like to work with? You know, this is one aspect I drive myself into play with green chemistry. It was a driving force, by the way, to play with green chemistry in order to be on the safe side. I do acknowledge that we don't have green chemistry in the country. We don't have even reticular chemistry. But thank God, at one instance, I insisted on the research team as well, in order to develop such thing, let me say, in the country. How can I pursue if I have obstacles? The question is to scholars, young ones, and of course to professors, those with expertise, much more experienced than us. Scholars to scholars, you can give an idea, but to be honest, sometimes you don't have any ideas where to communicate, where to stop, where to do so. Thank you so much.
Bassem, I think
I'm the best one to answer this question, because we are in Saudi Arabia, we are facing the same problem. I think this is very common in our communities and our universities. But to overcome this obstacle, like having to make an order now and you get it after 1 year or 6 months or whatever, is by design of your research project or proposal according to the existing facilities and existing resources. I'd like to make a new MOF, but when I went to KFUPM, I found that I don't have the single crystal. It's very hard to access the powder XRD. But in that case, I designed my experiments and research projects in the existing resources, and that's why I focus, for example, in mixed matrix membrane and membranes to make something to utilize what's existing. So I start to work from day one. But the people who was just waiting for resources to come, and then God bless them to have it after 1 year or whatever, they are still waiting. So this is the thing that I can advise, that just you need to, in the meantime, you order or make the orders and future plan, but you need to start with the things that you have in your hands.
You make it work. I think this is Professor Yagi's famous saying. It's always in the back of your head. Make it work. I don't care what problems you have. You make it work. Yeah, I just want to wake we're 10 minutes over right now, so if you want to go and get lunch, it's totally okay. I think we're all happy to stay up here and answer more. Just wanted to make sure everyone's okay with that.
Yeah, this is a very important point because a lot of countries, as we start, this is the first complaint. So I had this complaint in Saudi Arabia, and I said, I don't want to hear it. I want you to list what you have on the board. What do you have? And what they had was a lot. I said, then why don't you use what you have? Right? This is why I say science is transformational, because science, when you make a discovery, you can capitalize on that discovery. You just have to not restrict yourself to one direction, right? So they did. They took what they had and they made fantastic stuff, and he got started, okay, while he's ordering his favorite chemical. So I've developed over the years, including in my group in Berkeley, that I will not accept complaints, and I will not accept anyone that says it doesn't work, okay? It doesn't work is a license for everybody to sit around and do absolutely nothing. Okay, so there is absolutely no choice. Use your brain, you have your health, you have, as I said, the instrumentation, the laboratory, you have a university, you have income, do it. Get it done. Okay, so I'm very, very, very impatient when somebody says, in our organization, says it doesn't work. Look, they're all laughing. But the benefits of making it work is transformational. Right? So, and let me just say, if you don't make it work, who will make it work? Who would? The accountants, the lawyers, the people on the street? You're in charge of making it work. So let me just finish by saying that Edison, one worker came to Edison. Edison used to have a very big lab and said it doesn't work. You know what his response was? Make the damn thing work. It's not going to work for you unless you make it work. Okay, and that's really the principle that I follow.
Okay, Felipe. Felipe.
So yeah, I 100% agree, but I will also add one other comment is that we also need to push our organizations and our institutions to work in the direction so that we can fix this problem, so they can fix this problem. I know it is. Yeah, thank you. Yeah, that's right. So what I was saying is that we also that's part of the solution. We need also to push and to go to our institution, our organization, and I know it is very frustrating many times because they want to go in the easy way. But we know that we need things to be changed and improved to get also the better results. And we cannot just say we are going to do only what is easy, and we don't want them to have them in problems to order things that cannot be easily obtained. So we need to push them, and we need also support from the institutions and our organizations. That's also very important, in my opinion.
Okay, I think Karen wants to.
Just a quick remark on that one. It might seem impossible, but we have the same problem in Israel. There is the National Bureau of Statistics, which just feels very uneager to share their data, their results, or anything. So one of my colleagues, a PhD student as well at Tel Aviv University, was trying to make a research She asked for an access to the data, and she was granted a partial access a year after her request. During that year, she lost completely her patience. She took some questionnaires, and she went physically to interview the people, and she has built her own data set. So, like you have just said, if it doesn't work, make it work.
Okay, I think, well, that's two more questions here, and then we'll break.
Thank you very much. I'm Dr. Neela from Pakistan. I'm assistant professor of chemistry over there. I want to discuss two matters over here. One of the things that the gentleman draw the attention towards the problem which is already answered. I just want to tell you that in Pakistan, it's the same problem, that if we order some chemical, we have to wait for 3 to 6 months. And what happens that definitely, as the professor told us, the solution of this problem. But let me tell you that if there is a single step reaction and we don't have the required chemical which helps in converting, in the completion of this reaction, what we do that we go through the other possibilities. Definitely it would go through the step 1, then 2, 3, 4. It will be a time-taking process. But we don't have any other option, so we are following that pathway. My question is, right now, we are observing a distance between the academia and the industry. I mean, when we, right now in Pakistan, there are two funding agencies. One is Higher Education Commission and the other one is PSF, Pakistan Science Foundation. They are now moving, they are accepting, or they are, the projects, the funding projects which are on the applied science. Now we have a problem that there is a distance between the two, industry and academia. What measures we should do to increase this, relationship? How do we approach the industries?
Okay, let's answer that one.
Yeah, this one. Thank you.
Let's go.
I will come in because I know everybody in the system you mentioned. I would advise you to do the following. Pakistan is a member of IASA and we have been collaborating very closely. I would go back to HEC, which is Higher Education Commission, and I would ask the leadership the following question. Would it make a sense to think about the system which is based on multipliers? In Netherlands, where I come from, we have had this discussion 10 years ago where we put up together a joint program co-funded by the Basic Science Foundation of Research, together with the industries, under the conditions that the researchers will be able to come with the joint consortia. And that actually provided leverage of like tripling the budget of the Science Foundation for this particular program. I think the leadership of HEC, I know very well, would be very much open to that. In Pakistan, just propose the partnership program which should be co-funded. 60% money coming to you from HEC and 40% coming from the industry which wants to be affiliated with the project. This is a concrete proposal which is working in other countries.
Nemi?
Hi. Yeah, I would like to answer this because, well, I'm from India, and when I was at IASA, I wasn't funded by my NMO, which would be United States, because I was representing a US university. I was actually funded by Ferrero's corporate, so the chocolate company Ferrero, because they were interested in the applied part of my research, which was food production and supply chain. Even though, so they wanted me to research on sugarcane production in Hyderabad because that is, they saw my nationality and they were like, I could be able to do it. But again, I was like restricted based on my proposal, and I really wanted to work on my thesis, which was in United States. So there was this, so I thought that there was a distance between like what I'm doing at academia versus what I'm doing in industry. But once I got to meet people from Ferrero at IASA, they were actually very interested in just the methods I was developing. And they gave me a full rein. They were like, do whatever you want to do for your research and we'll just talk. So people are interested. It's just first, how do you package your research. That's main thing, because like you said, like applied sciences or applied engineering would just be more useful for them. And then second, just like having this platform where someone comes and says like, here's a candidate who might be able, who needs funding, and or like, here's research which needs funding, and you guys should be looking at it. That's it. Thank you.
Okay, last question. Oh, there's a
Good afternoon. My name is Henry Chaparro. I come from Colombia. I'm a medical doctor and a geneticist over there. In my university, I'm a faculty member of one university there. We have an important problem with emerging researchers. We don't have emerging researchers, yes. In the last 3 years, particularly in medicine, we don't have anybody that have decided to become research their life project, and that's concerning me about. We have opening summer schools for research and nobody is enrolling, so we have to close them. Local research is disappearing, so one strategy is bringing abroad researchers for making the research in our faculty. So I think that one-on-one mentoring should be started at the undergraduate programs and not wait until they become PhDs, because we assume that people that start a PhD is people that already decide to become a research their life project. So I don't know any of the panelists have a recommendation that I could take to my country, to my faculty, and empower research in young people. Thank you.
Thank you. A good question, and I understand the situation. I am very close to you in that case. So let me say that a lot have been said these days in this World Science Forum about regional cooperation. And also let me say that right now in the lab, 60% of the PhD students we have are from Colombia. So that happened because CONICET, which is our National Research Council, created a type of fellowship for Latin American people to come to Argentina. So there are a lot of difference between these countries, although they are close to each other. And one of them is that in Argentina, a PhD program is free. Actually, you receive a fellowship for doing it, while in other countries in Latin America, you have to pay for a PhD. So, I mean, for a person of that age that has a family or have a family in that case, so it's important that that work that they do during the PhD is recognized. So then you have a critical mass now that is of students that is doing a PhD. So that will transform in the near future the amount of people that is coming back to Colombia with a PhD. So those people in Argentina are also somehow motivated to do outreach. So our responsibility with the society doesn't end in the lab, right? So because of the PhD program, those people are teaching young scholars. So they are teaching Colombians and other Latin American people in the College of Chemistry in Cordoba. So I think that that would solve the second part of your question, right? So you need critical mass. So we have the means to train them. So the next question is solving where they are going to work when they have the degree already. So I think that the regional cooperation is a key player to solve this problem, and also to address some of the needs that we have in the region as a scientist and as a professors as well.
Thank you, Alejandro.
Let me add to this, going back to some of the previous comments which some of you made here in the room. I think this is a problem which is not only in Colombia. I mean, what is the mass and the quality of the generation coming to science? And I think it goes back to the very roots of the science culture. I think we, a couple of us here in this room, but also our peers in the world, privileged ones, should help in our own countries to create a real science culture which starts from the small child. You know, I traveled most of the countries of the world, and you may think whatever you like for the United States, every time I go there, I still enjoy their science culture, science shops. My wife and I go everywhere to the museum and to see, you know, yet another new thing they invented for the children. Science class in the basic school in US is a joy. Children like it. I think this is something we need to do everywhere. We need to just invest in the long-term science culture where this interest, this genuine interest in discoveries will be created. It's not a case anymore in Europe, I am sorry to say. It's not a case anymore in, for example, Russia, which used to be there, one of the best in the world. We are losing this. So I think one of the challenges for us leading this type of segment should be to help a little bit, to communicate this very basic need to have a culture of science within our systems.
Thank you. Okay, I think I'm going to end it there so people can go to lunch if they want. But please join me in thanking the speakers and the panelists. And I think they'll all be up here if you have additional questions. So thank you for coming.